Good afternoon, everybody. This is a live emergency extreme weather briefing as the northern plains are about to go absolutely nuts over the next 7 to 10 days. Also, the Corn Belt with a series of Ridge Rider events riding over that summertime ridge that's going to be dominating the Mid-South, a little bit south of where that H is located. We also get a semi-permanent trough off the Pacific Northwest, and that just continues to send wave after wave of energy, jet streaks ejecting around. That's going to light up the central Montana area up to Alberta, up into southern Saskatchewan, and the western Dakotas. But meanwhile, watch these ridge riders, little jet streaks that ride over top the summertime ridge over the Mid-South. That could bring a conditional threat of supercells and tornadoes to Iowa, portions of northwestern Illinois, southwestern Wisconsin during tomorrow, Monday evening. But today, there's an enhanced risk. Basically, a large swath of Montana, central Montana, well to the west of Billings, Helena to north of Billings, all the way into western North Dakota. We're going to break down that setup as well. That also includes an isolated tornado threat, and that's associated with one of these jet streaks that are lifting off to the northeast. And then there's another one that comes in back behind it toward the end of next week through the weekend that could bring big-time tornado potential to North Dakota, a large swath of central and eastern Saskatchewan getting very active. And I'm going to have to decide between these Ridge Rider setups, basically convectively enhanced jet streaks that are riding over the north side of that ridge. Those are notorious for producing tornadoes across this zone, across the Corn Belt. You get corn sweat out there that happens. You get all kinds of deep moisture. Some of the highest dew points anywhere in the world are found in the Corn Belt because of that moisture, that sweat that will come off the corn. Basically, transpiration is what that's called. When you combine it with evaporation, it's evapotranspiration in general, kind of the flux from the plant surface, puddling that can happen, evaporation. But this is the 0 to 3 kilometer energy helicity index looped over the long range. And watch our two zones. Watch the Ridge Rider setups. This basically shows where the surface-based instability, the greatest heat and moisture coincide with the favorable wind shear for tornadoes. And you can also see some of these northern plains events going. This is a loop over the next 7 to 10 days that shows you that you basically have a push and pull between the Corn Belt, where you get a lot of these Ridge Rider setups, southeasterly moving supercells over the top of that ridge with very deep moisture, big time heat this time of year, dew points into the upper 70s, even near 80 across the Corn Belt, Iowa into northern Illinois. And then you get these northern plains setups that get going. And then there can be a little bit of an attendant jet streak over the top of the ridge. That could happen as well later on today. But today, the threat is the enhanced risk for large hail, damaging wind, and a threat of tornadoes. It looks like storms are going to develop off the higher terrain, south central Montana, even across northwestern Wyoming. It's possible that other storms could initiate just north of Gillette up to near the Biddle area. Those could turn and then mature as they move east-southeast toward the Broadus area. Over the southern tier of counties in Montana, the temperature dew point spreads are a little bit large, but you get up into central Montana where those deep easterlies are located, and that's where you get very reasonable cloud-based height for even a tornado threat. And I think that the Storm Prediction Center has boosted the tornado probabilities from this zone across central Montana, even into western North Dakota. There you can see a couple of those storms. And watch the path that they take. When they first develop, they're moving off to the northeast, and then as they mature and progress a little bit to the east of that jet streak, and then propagation starts to dominate, then they start to turn east-southeast. Later on this evening, that's going to be like a 7 to 10, even 11 p.m. type time frame that they finally arrive in western North Dakota. But they develop off the higher terrain first, possibly some more flash flooding out there. I know some of the local rivers are quite full up here, especially off to the west, where there's been a ton of rainfall across southern British Columbia and into northern Washington. These storms develop off the higher terrain west of Billings, well west of Billings, west of Helena. They move off to the northeast and mature as they hit that belt of surface easterly flow. Another one goes up near Glasgow into northeastern Montana before curving off to the east-southeast into northwestern North Dakota, well to the north of Dickinson, basically up near the river system, even north of Teddy Roosevelt National Forest. Great place to chase up there near Sidney, Montana. Up Sydney, Montana, crossing into the border there. We were chasing a lot there on June 10 last year, 2021. That one could have some tornado potential. Then your main wind bag arrives, and there is a chance that you could even get a little bit of development off of that outflow boundary in northeastern South Dakota. But looking at some of the RAP analysis, I wonder if some storms are going to be able to form off the northeastern periphery of the Black Hills and then move into that big cape and easterly flow. Modest bulk shear, but there might be enough bulk shear to get a couple of supercell storms that are able to form off that topography on the northeast corner of the Black Hills, possibly producing as they move up into central South Dakota late. There is also a very conditional threat, maybe an isolated supercell late near evening, McCook and areas off to the east of McCook. But really, anytime you get kind of deep into that ridge, when you get the anticyclonic curvature aloft, usually there's some subtle subsidence that will dominate down there in those borderline cases when it looks like there may or may not be a strong enough cap to preclude the initiation of supercell storms. If I were chasing today, I'd be sitting right here in central Montana, just to the north of that wind shift where you get due easterly surface winds, more of a 75 over 58 type of a profile up there. Definitely low enough cloud basis to even get a tornado or two. And I want to show you a couple of the RAP analyzed fields and really the RAP forecast, but this is the RAP forecast for 4 p.m. Mountain Time, 5 p.m. Central. And anytime you get this is the surface, these surface winds. See how all these flags are pointing into the east where the wind is coming from? You basically have uniform easterlies all the way across the entire state of Montana, even all the way up to the mountains. It looks like there is a surface axis, a surface ridge axis as well, where east of that line, east of Billings, surface winds are a lot more due easterly. To the west of that line, surface winds are a little bit more east-northeasterly. That might enhance some of the hail sizes with some of these supercells that do come off the higher terrain over southwestern Montana, move into that deeper moisture, and you can definitely see some pooling of the moisture along the higher terrain across north central Wyoming, well to the west of Billings. Definitely could get some pooling of the moisture. But once these storms are able to move in to those enhanced easterlies, you can even see some storms that try to go right up on the axis, well to the west of Glasgow, up near Glacier National Park. Some storms could go up. These are definitely going to mature and move into that belt of easterly winds. Anytime you get this large swath of due easterly surface winds, that's also going to enhance the bulk shear. When those are underneath about 30 to 40 knot mid-level flow, you have to add the magnitude of these easterly winds to compute your bulk shear in the 0 to 6 kilometer layer. And you're probably talking at least 40 knots of bulk shear available to these storms, which definitely encourage the formation of supercell storms. Looks like at about 3 to 4 p.m. they develop off the higher terrain, and a couple in central Montana off the elevated high plains further north. So I do want to show you also the wind shear, the effective low-level helicity that's going to be across Montana as well. It is a little bit borderline for a tornado threat. That's why the enhanced risk is mainly for very large damaging hail. But it is sufficient for tornadoes, especially within this belt into central Montana. That's where you get low enough cloud bases to realize a tornado threat, low enough LCLs. Temperature dew point spreads of about 15 degrees are definitely supportive of tornado potential. And the RAP is definitely showing the development of these isolated storms into central Montana that are going to move off to the east at about 20 knots with increasing low-level wind shear through evening. It stays light a lot later in Montana, up here near the Canada border too. You're probably going to be chasing into the late evening, very late up there. So these storms are going to probably be some legendary structure up there into central Montana, maybe even a tornado. They are quite rare to find in Montana. We did last year around June 10, 2021, out near the Montana-North Dakota border. We certainly saw tornadoes, a couple of which did happen on the Montana side. But it is a very difficult place to see tornadoes. It's a big state. It has complex topography. Usually your easterly upslope flow will extend all. The mountains are in the western edge of Montana, so you have this huge area of high plains and little pockets of elevated terrain down there near Custer National Forest, south central Montana to the west of Broadus. There's some elevated terrain that can fire some storms. High plains up here into central Montana. This is where a lot of the tornadoes happen, and there's not very many chasers up there either. Radar holes, the HRRR doesn't do as good up here either, so a lot of of chasers don't like to venture into the central portion of Montana. I know my good friend Jordan Hall is going to be out there chasing central Montana. He's a local, grew up in Montana. Excited for him to chase this potentially legendary structure setup and maybe even an isolated tornado, especially as we get closer to evening once these storms start to turn into those due easterly winds. These are the upper levels at 22Z. This jet streak is what fires those storms off the higher terrain, but along the leading edge of the nose, you still get that easterly upslope flow, just gradually going up the terrain from eastern into central Montana, and that could fire some of these isolated storms, potentially legendary motherships across central Montana. Looks like a couple fired to the northwest of Billings, too, off the elevated plateau. High plains to the north of Billings. I do think that there's going to be moisture issues across the southern tier of Montana. Couple of counties down there and near the main interstate, Billings, all the way up to Glendive. Basically south of I-94, I think, is going to mix out. You're probably going to have near 30, potentially even 40 degree temperature dew point spreads. You'll probably have another high base mothership that will develop out near Biddle. That's going to move off to the east and eventually turn east-southeast over the north side of the Black Hills. Broadus, maybe near Belfouche, late evening. That supercell storm could arrive into some of the deeper moisture and develop a tornado potential. But definitely does look like a pretty substantial severe weather day across Montana. We definitely recognized it yesterday. Tried to get a couple of storm chasers to go up there, and then the SPC issued the 2% a little bit further south, I noticed, down into the Nebraska zone. Tried to, oh, there we go. Got it. Wanted to show you a deeper dive on the HRRR and the satellite imagery. First, here you can see the satellite imagery. Obviously, we've got jet streaks that are coming. This stuff all basically needs to clear out of Montana, but you can see that these clouds, MCSs, are lifting off to the northeast. Looks like possibly an elevated mix layer, some dry mid-level flow back behind this. That will probably lead to some destabilization right along the mountains. But really, you can see tons of heating along the southern periphery of those complexes of storms and off to the south. Instability definitely isn't going to be an issue. These storms are going to go off the higher terrain, no problem. Here is the HRRR surface-based CAPE, and we are going to compare some of these convective allowing models because we know that the HRRR model tends to overmix the dew points across the high plains. And that's probably why you have some of these modest dew points down here. You can see the general area of greater moisture across central Montana. There's also an area of CAPE that hugs the mountains, a little bit of pooling of the low-level moisture across the higher terrain, Sheridan, up to the west of Billings. But this area here is the moisture, upper 50s dew points, temperatures more into the middle 70s, down into this environment where you get some of the lower CAPE values. Even though you have much warmer temperatures, you have a little bit lower dew points too, and you have those higher cloud bases, certainly. And that's at 21Z. You go to 22Z. Look at this thick area of CAPE upstream. Even though it's only 1,000 to 1,500 CAPE, I still like this high plains environment and this concentration of good shear out ahead of these storms that will be developing off the mountains at this time. Also some decent shear further into central Montana along the elevated plateaus there. Just randomly picking an HRRR sounding. You've got about 28 degrees in a temperature dew point spread. Those are pretty high cloud bases still, and that's the HRRR though, which does tend to overmix the moisture. Still though, it has a 56 dew point. And no cap, of course. You can see some decent CAPE, dry slot in the mid-levels coming in, an elevated mix layer, a ton of directional shear in the low levels. Your 0 to 1 kilometer shear vectors are quite shallow, generally about 15 knots and lower. That's why it is a relatively marginal tornado threat. But a lot of times here at the high plains, when you get kind of a larger 0 to 2 kilometer vector, for example, it seems like that can still be sufficient to produce tornadoes. I think that the below cloud-based environment at the lower pressure at higher elevation, it's easier to dynamically pipe a tornado vortex from 2 kilometers all the way down to the ground. You also have a lot of this low-level cape as well, steep low-level lapse rates. And your directional shear, you go up to about 2 kilometers. Uniform easterlies in the lowest kilometer or two, definitely the lowest 2 kilometers, and then you flip around to westerly. So a lot of times your 0 to 1 kilometer shear indices don't really capture the true magnitude of the wind shear available to these high plains tornadoes. Campo, Colorado, for example, had very minimal 0 to 1 kilometer shear, 0 to 3 kilometer through the roof, and you had one of the most photogenic tornadoes of the last couple of decades out there. This profile definitely supportive of long-lived mothership supercells, large hail as well, and you might get the chance of an isolated tornado or two. You have a lot of easterly winds in the lowest kilometer or two as well. That bends the hodograph back into that quadrant. You also have a lot of bulk shear, especially over top those surface easterlies across Montana, and that could set the stage for an isolated tornado. The Storm Prediction Center did issue a 5% tornado threat across central Montana and areas off to the north. Really quickly, I do want to compare the surface dew points to the 3 kilometer NAM, which usually has a much better handle on surface dew points. You can see just north of that line is where you get the best dew points, even some 60s up near the Canadian border, north central Montana. It's that belt of the upper 50s that could happen. But as I mentioned, the HRRR often overmixes the high plains. And look at the 3 kilometer NAM. It even has upper 50s down into southern Montana, near 60, streaming all the way. 58, and 58 is a lot different from a 55 or a 56 dew point across central Montana. Does look like a much better moisture situation across the state. Looking at the wrap, look at that belt of big dew points that the wrap is showing. And the wrap is kind of my go-to model for the high plains. It does a really good job for some reason in the high plains. It's gotten me a lot of tornadoes over the last 20 years up here, and it does a really good job at showing where these areas of deeper moisture will hold out against mixing. Look at in southern Montana, you get a lot more mixing. The southern couple of counties, including Billings, you get a lot lower dew points, greater mixing. But to the north of that, you get deep dew points, upper 50s, near 60, that are possible across that environment. And I tend to believe the wrap across this zone over any other model. And I bet that if we click a forecast sounding, definitely more of a tornado type sounding, 76 over 63, low-level thermodynamics. That's the problem. If you live and die by the HRRR model, some geographies will bite you in the ass. That includes the high plains a lot of times, especially the northern high plains where you get runaway mixing. But look at the wrap here. Central Montana, it's got temperatures in the middle 70s. It's got dew points into the 60s. You're probably not going to see middle 60s up there, but at the very least I could see near 60, maybe the low 60s. And even have a little hint of a northerly component to the winds, which would enhance the very large hail potential. Not very much in the 0 to 1 kilometer layer, but the 0 to 2 kilometer shear vectors are a lot larger, and a lot of times your strong streamwise vorticity intake will happen between about 2 and 3 kilometers across the northern high plains, which, at least in my experience, has been sufficient to generate tornadoes across the high plains. I've seen a bunch of tornadoes in eastern Wyoming, a couple in Montana, a ton in eastern Colorado, eastern New Mexico as well, even Alberta into Saskatchewan. I use this model for forecasting. Definitely does work a lot better across the high plains. If you live and die by the HRRR, and especially the composite reflectivity pattern of the HRRR, you're going to get in trouble. And look at that environment across Montana. I mean, this entire pipe, you have this little ridge axis through surface ridge through the central portion of the state where you have more easterly low-level winds. And boy, if the WRAP model verifies, you're going to be talking about some really photogenic supercells that evolve across central Montana, eventually approaching the North Dakota border late, probably like 8, 9, 10 p.m. That's when these are going to be approaching the North Dakota border. They're just going to move right and then turn east-southeast into that deeper moisture. As you get a little closer to 9 or 10 p.m., you're probably going to have a pop in those dew points as well over western South Dakota into southeastern Montana. You could also see that the WRAP hints at this streamer of favorable moisture around the northern edge of the Black Hills. And the WRAP model, the high-resolution WRAP, does a really good job at picking out how the moisture is going to funnel over the terrain. Does it funnel over the north side of the Black Hills? Does it wrap around the south? Does it do both? And in this setup, it looks like it wraps around the north side of the Black Hills. So I wouldn't even be surprised if a couple of those storms that develop near Gillette up toward Biddle, they're going to probably be high-based supercell storms, maybe even a windbag. And possibly once they hit this environment in the northwestern portion of South Dakota, they could go nuts when they hit Belle Fourche. I've seen it happen a lot where these storms will turn off to the east-southeast, move into this environment across northwestern South Dakota, and start dropping big-time hail, impactful damaging winds, and even an isolated tornado. But you certainly want to target this environment up into Montana if you want to get the goods. After today, I do think that the threat shifts to Iowa, and that's what I'm watching. I've already got a flight in to Iowa, and I might just have to chase for many days in a row. But this is a system late next week through the weekend that I might also have to chase. Watch when this starts again. This is Sunday. This is today's system. And then there's a Ridge Rider system right here, that little bird fart of a Ridge Rider trough that dives off to the east-southeast. It's probably going to lead to more severe weather across the mid-Atlantic. That's what I'm watching tomorrow. Northeastern Iowa into northwestern, even west central Illinois, definitely does have the potential conditional threat of supercells and maybe even some tornadoes. And then this bigger trough ejection comes out of Montana and across North Dakota. Also going to have to keep a very close eye on that. But I do want to give you a quick breakdown on the Corn Belt. And I do believe that the WRAP is a pretty good forecast model for the Corn Belt. Obviously, you get some of the best moisture conditions out there. It's really hard to mix out the Corn Belt as well. But I do think that the threat of supercells is extremely conditional across the Corn Belt tomorrow. If a storm goes, it's probably going to produce tornadoes. This is an outflow boundary as well that's left behind by complexes of storms. And possibly in between that notch, you get some well-mixed air, more southwesterlies in that location, more backed southeasterly winds, deeper moisture, central eastern Iowa. What will probably happen is these will develop in the slightly well-mixed air mass near Mason City and could turn east-southeast into this environment. But one thing that I noticed that has me a little bit concerned as to whether storms are going to initiate is it does look like the jet streak, the timing of it's a little bit fast. I think that if it were slower by about 3 hours, then I think that this would probably be a likely tornado event, possibly even a big-time tornado event across north-central Iowa, moving into eastern Iowa. But if a storm does develop, it's going to cause problems within that environment. You're looking at the 0 to 3 kilometer EHI at 7 p.m. Monday evening. 7 p.m. Monday evening. And that little subtle jet streak that we were talking about, it does prompt a southwesterly low-level jet. You have about 20, 30 knots out there. But usually when it's not tight, when the gradients of the low-level jet are really diffuse like this, a lot of times that's also a sign of some subsidence, not a ton of low-level convergence either to initiate storms. There are a couple things that you need to initiate storms. You need low-level surface convergence, and you also need upper support. And if you don't have one of those ingredients, then it's definitely a more conditional threat for initiation. It looks like you do get some storms across northeastern Nebraska that try to pop by Monday evening, but at least the HRRR is not firing anything across the target area, despite those really favorable thermodynamics across the zone, favorable atmosphere. The 3 kilometer NAM, though, does fire storms. I thought. Tries to fire them at about 9 p.m. These are likely going to be more elevated along the outflow boundary, but from northeastern Iowa back into southwestern Wisconsin. See how this low-level jet has a much tighter gradient too, at least by 9 p.m. on it. There's likely going to be quite a bit of low-level convergence associated with that tighter gradient, and that's what is happening on the 3 kilometer NAM. You go over though and look at the HRRR, and you're not seeing that tight gradient in the low-level jet. You do see it, though, in the 3 kilometer NAM. Let's see if we see it in the WRAP. We're not far out enough in the WRAP, obviously. That's at 0Z, and it definitely tightens up. Finally initiates storms right at the nose of the low-level jet in northeastern Iowa, maybe into southwestern Wisconsin. That has some potential. And if those storms are able to develop, they are going to be moving into an environment that's extremely supportive of tornadoes right along this outflow boundary that becomes a pseudo warm front. A lot of times the storms will initiate a little west of that, and then they mature and then slide southeast into that gradient. But there definitely is a robust capping inversion. Look at it on the 3-kilometer NAM even. I mean, that is a big capping inversion. Temperature is very stable along that gradient. Even though you do get these massively curved photographs, a lot of times that's a sign of a decoupled boundary layer. And that's the capping inversion. That little area of warm air just above the ground, that's a capping inversion. Further west in that blob, still a very stout capping inversion. Out near Davenport, capping. So the 3-kilometer NAM is definitely showing quite a bit of capping. It's going to be very difficult to generate storms within that environment. If they do fire, though, they're probably going to be fairly significant. 0 to 1 kilometer EHIs do appear to be maximized up near Ames at about 9 p.m. But look at that inversion. That's why the low-level wind shear is so robust, because your low-level jet accelerates just above that capping inversion. See how that red line increases right there? It's hard to get surface-based parcels to pump through that capping inversion unless you get immense lift or surface convergence, and even then it's tough. But what happens is this low-level jet, southwesterly low-level jet, will accelerate just above the capping inversion, almost blocking it off from the surface air. That's an inertial oscillation where your low-level jet will increase, and you're just not able to tap into those deep dew points that are trapped below the capping inversion. Dew points into the mid and upper 70s. Very favorable wind shear, though. Any storm that gets going in that environment is going to produce. And also keep in mind that we're looking at 2Z. And of course, the capping inversion is going to ramp up. Let's look at 0Z and see what that inversion looks like. It does look like it's possible to get surface-based convection. The convective temperature is near 94 degrees, though, so you're going to have to get extreme temperatures into the middle 90s with such a stout capping inversion. You do get near convective temperature right along that outflow boundary. So, I mean, you do get into the lower to middle 90s, so it's going to be very close if that boundary can initiate it. You're going to need all the corn sweat in the world out there. You're going to need those big dew points. It looks like you even get above an 80 dew point. 87 over 82. Dominating corn sweat right there. Notice how your cap in that environment, which is probably an erroneously high dew point into the low 80s there, but notice how you easily breach the cap once you get those big time dew points along the outflow boundary. Probably runaway evapotranspiration off the corn sweat, but you can get dew points into the low 80s out there. That's not out of the realm of possibility, but with those very high temperatures and dew points, the cap is of course a lot weaker. And it does look like you get surface-based instability. Thick cape up here. A lot of times this big, thick cape doesn't really produce as much of the way of hail, like what we're going to get across central and eastern Montana today. But you get real tall updrafts at least. Certainly get a lot of stretching and some tornadoes. Let's look at the HRRR, though. Look how different the dew point field is. But you still get at least 75 dew points up there. Probably, more than likely, it's going to be an average of those two models. More like this would be a average representation. Outflow boundary appears to be a little bit further south with this. One concern that I had with this system is the late arrival of the very subtle jet streak, and we can see it at 500. This is the jet streak right here, and it actually passes through the area at 20Z a little bit too early. 18, 19Z by early afternoon. You get this ridge riding jet streak moving through northern Iowa. And I'm a little bit concerned that this is coming into this zone too early. Usually the right entrance will provide some upper support, the right entrance of this jet streak. It's very possible that this right gradient of the entrance could lag back just a little bit through peak heating, and as you get closer to 0Z, maybe it'll initiate some storms. But if anything, you get height rises. You get subsidence back behind in the wake of that jet streak, and it's over lower Michigan by 8 or 9 p.m. And that's really why, likely more the reason why the HRRR does not fire any convection across northeastern Iowa. But the 3-kilometer NAM certainly does, but it also has those near 80-degree dew points just to the north of Des Moines, which also could happen. I'll be watching the surface map very closely today. Storm Prediction Center has a slight risk out for this zone. I believe a 2% tornado probability, basically to account for the conditional risk of severe weather or two. There's your enhanced risk today. Large 2% zone across the upper Midwest. That includes Minneapolis down to just north of Des Moines. Quite conditional. And then it looks like the threat shifts back to the high plains on the day 3 outlook. Another slight risk that arrives into West Virginia. I was considering covering that event for flash flooding. There is also a slight risk from the Weather Prediction Center for flash flooding for those ridge riders that are going to be running into the western Appalachians. Certainly could get some flash flood potential there into West Virginia, and have to keep an eye on that. Look at the flash flood watch across eastern Montana too, in anticipation of those clusters of storms that will move through. Again, looking at the long range really quick. So this is definitely setting the stage for a very active Canadian prairies. Alberta, Saskatchewan, and northern plains of the U.S., Montana into North Dakota, and it's because of this semi-permanent trough that is off the Pacific Northwest, and that's largely forced by the warm blob of sea surface temperatures with the North Pacific Oscillation across the North Central Pacific that forces the ridge over the North Pacific further west, and you get the desire for this semi-permanent trough to form off the Pacific Northwest into Western Canada, and then you get disturbance after disturbance, swinging through the Northern Rockies, and by the time they arrive on the high plains of Alberta, they usually result in big severe weather. You have the moisture hanging up here. You have lower LCLs hanging like usually just to the north of Calgary. And it does look like these do eject downstream across portions of Saskatchewan and North Dakota toward the end of next week. That would be about Friday into Saturday next week. Look at this trough ejection into southern Saskatchewan next Friday and Saturday. That's a big time trough ejection, and it's likely going to be associated with a much stronger low-level jet than is being indicated here over central Saskatchewan. Looks like another pocket of a low-level jet into the Dakotas. North Dakota, South Dakota. That's going to be next Saturday on July 9. Big time trough ejection. You also get this high pressure area centered over the Four Corners. The return flow on the backside could definitely lead to an energized monsoon season. You have Hurricane Bonnie over the tropical eastern Pacific that could lead to an influx of moisture in the tropical Pacific as well. And a lot of times this time of year, you have to decide between chasing the monsoon on the western edge of that high. There's the high. And of course, you have a counterclockwise spin around it, so that gives you southerly flow along the desert southwest. It pumps some moisture from the Sea of Cortez and the tropical eastern Pacific across that zone. But you also have this beautiful trough ejection around July 9 and 10 into southern Saskatchewan. I think this is going to result in some tornadoes out there. Regina to Saskatoon, southeastern corner of Saskatchewan, big time trough ejection. And you also get a little ribbon of a jet streak into the northern plains, poking into the Dakotas. That could lead to a little bit of an enhanced low-level jet too across the central and eastern South Dakota, North Dakota area. Even despite this ridging aloft, sometimes that can suppress the storms, but when you get a little subtle jet streak like this hiding down further south, sometimes that'll arrive in the greater instability. And if not, it'll ride the ridge and then become a ridge rider system over the Corn Belt, Iowa, northern Illinois, southwestern Wisconsin, southeastern Minnesota. That certainly could happen as well. Thank you, everybody, for joining me. Hit that notification bell. Thinking about activating storm chase mode here, southeastern Saskatchewan into northern North Dakota next weekend. Also considering rolling into Des Moines tomorrow morning. I've got a flight right now that leaves at about 6 a.m. That's going to get into Des Moines tomorrow, but it's conditional. We're going to have to look at the 0Z models tonight to verify that. But those are big dew points, 70 dew points being indicated by the long-range GFS. Look at that reservoir of dew points also sitting over southern Manitoba. The day before, this would be Friday. Look at that arm of moisture in northern Saskatchewan, wrapping all the way across the high plains. Red Deer up to Edmonton. Some low 60s dew points that far north. Another arm of moisture in northeastern Montana, too, on the long range. And then it looks like on Sunday next weekend. Look at this. Big belt of some strong westerlies across portions of the northern plains, Minnesota. That's going to be very active as well. You're definitely going to peel some complexes off that. Possibly some derecho formation. Look at those dew points down there too. 70s dew points sitting there. That would be next weekend. Looks like a very active severe weather pattern. North Dakota, then focusing down across the Corn Belt again. Friday, it's going to start off across the high plains of northeastern Montana, North Dakota, maybe up into Saskatchewan too. This week we got Monday, Corn Belt Day, northeastern Iowa. Today we've got central Montana. Tuesday, you bring back the high plains up here across eastern Montana and the Dakotas. Look at that threat into Montana, everybody. But you also get the potential of ridge riders into southeastern South Dakota. This is next Tuesday. This is a couple of days. I believe that the Storm Prediction Center has a slight risk across the high plains of Montana and into western South Dakota. A lot of times those helicities are due to northerly surface winds. Look at those northeasterly surface winds banked up against the mountains. A little bit further north, though, you can get into those more due easterlies. East-southeasterlies even. It's just the nature of the way that the terrain is shaped out in Montana. So you get more of those southeasterly low-level winds. So it does look like a very active northern plains and Corn Belt is ahead. In the coming days, I am planning on activating storm chase mode. Dominator 4 is still in the shop, so I'm going to be using the rental Dominator on these chases. But classic this time of year. You get ridge riders in the Corn Belt, Iowa, and into northwestern Illinois, central southern Wisconsin, central southern Minnesota. Watch these bright colors that illuminate across the Corn Belt. Those are ridge riders, east-southeasterly movers, disturbances that will go over top the dominant anticyclone across the Mid-South. And then you also get the high plains that go nuts in the Canadian prairies. And also watch Alberta toward the end of next week. Could go active. So thank you, everybody, for tuning in to this weather report. Be sure to ring that notification bell if you don't want to miss any live storm chases. I appreciate everybody for tuning in to my live briefings. Thank you, everybody. Thank you on Facebook. Thank you, Twitch. Thank you, YouTube, as well. Thank you, everybody, for tuning into these. I gave myself an award earlier today. I gave myself a Big Mac for nailing this high plain setup and this Corn Belt and kind of feeling out the pulse of the season-to-season extreme weather this year. Enjoyed the Big Mac on this July 3rd. Everybody have a great July 4th. Hopefully you see some beautiful fireworks if you want to tonight or tomorrow night. I've got some big fireworks, including the Total Blowout. That's what I'm most excited about, the Total Blowout firework. I know it sounds like something that you'll often get when you're storm chasing out there, a total blowout, but there's also a marginal risk down here at my mom's place in upstate South Carolina where we could get a marginal threat of severe weather as well. So I'm going to have to keep an eye on that with the drone maybe even get the bird in the air, dominate the bird. But thank you, everybody, for tuning in to this live weather report. Thank you, moderators. Never stop chasing.